All right, so we have Chris, Michael, and Chantal here with us for this focus on the SDLE, Life of a Linked Dataset presentation. They've got a whole coordinated back and forth with each other that's going to be really impressive. I'll be moderating the Q&A session when it comes to that, but I believe I'm handing it off to Michael to get things started. Sorry, I made you mute, and then now I'm going to ask you immediately to unmute. Okay.
I'm just looking for the slides to share the slides, and I'm just going to. I don't see the slides, even though it's open on my screen. Can I go with this, maybe? Can you see the slides?
Looks promising. Nope, we just see a desktop. Oh, okay, so we see the presenter view.
Which is what you want to see?
No, it's what you want to see.
That's what I want to see.
Yes. But I may be able to share slides on your behalf if you want.
Sure, you might as well, because I'm not going to, they're not animated, so.
Okay.
It worked fine in the testing area, but for some reason.
Good enough. I will make that happen. Got a lot of stuff open here. Okay. Screen 3, sure.
Okay. Thank you. Thank you for doing that. So first, I'll just introduce myself. I'm Michael Tjepkema, and I work in the Health Analysis Division at Statistics Canada. And today, me with my colleagues Chris and Chantal are going to discuss, how does one create a linked data set from A to Z? Next slide. So really the goal of this presentation is not to get into the real details, but to kind of give you a broad overview of the main steps from starting with a research idea to the creation of a linked or integrated data set, which would then be placed into the research data centers. And we're going to use the Canadian Census Health and Environment cohorts as an example of this process. Next slide. So overall, there's probably 7 main steps that are required to make this happen. Step 1 would be the research goal, or why you're doing, or why do you want to do the linked, create the linked data set. Step 2 would be the approval process to get that data set linked. Step 3 would be working with the social data linkage environment to do the actual linkage. Step 4 would be the assessment of that linked data set. Step 5 would be the creation of weights if you needed them, as well as vetting rules. Step 6 would be documentation. And step 7 would be the actual placement of the file in the research data centers. So we'll go through each of those steps in a little bit of detail, and hopefully that will give you an idea of what is required. So step 1, research goal. What are we trying to achieve? It's probably the most important step of all the steps. You really have to figure out what do you want to achieve in your research question. And once you have that figured out, you will then want to decide, well, does Stats Canada have the data sets to help you answer this question? And if we do have the data, have the data already been linked? Is the linkage technically feasible? These are some of the initial questions one might have. And for those that may not be aware, the data that's currently available in the research data centers, we have a link on our website that shows you what's in the RDC and the research data centers. We have another part of our website that shows all the approved microdata linkages over the past, 10, 15 years. There's the hyperlink for this. I assume the presentation will be shared. And then finally, what is the social data linkage environment doing? What files do they have in their depot? And there's the link for all the different data sets that reside and have been linked in the derived record depository, or the DRD. For the CAN check, I'll just give a really brief history of you know, how this data set became what it is today. For those that don't know, in the early 1990s, there was a feasibility study of linking the 1986 census to both cancer and mortality data. This was for some cancer registries in Manitoba, I believe, and they did a feasibility study, which was completed in 1996. A few years later, there was a presentation that was made to the Office of the Privacy Commissioner, because this is really the first time that we wanted to make a linkage with census data. The formal approval was submitted and approved in 2003 for the 1991 census linkage to mortality outcomes. And a few years after that, we published an article in Health Reports in 2008 called the Canadian Census Mortality Follow-up Study. This was some work I did with a former colleague who is now retired, Russell Wilkins. A couple years later, in 2010, we added data to that linked data set to include historical postal codes as well as cancer outcomes. 2 years later, we placed the file in the research data centers. In 2015, we extended the mortality follow-up, the cancer follow-up, and then postal code file. Then we thought to ourselves, well, this is great. We have one cohort. Let's have some more. So we created a 2001 census tax mortality cohort and published a paper about that cohort in 2016. We did the same thing again in 2018 and created the 1996 census tax cohort, which we rebranded the Canadian Census Health and Environment cohort. And then during this time in 2014 and 2015, the social data linkage environment was born. And that kind of leads me to the next slide. You know, with the creation of the social data linkage environment and internal funding, there is now an opportunity to create a series of standardized census health and analytical cohort files, starting with the 1991 census all the way up to 2011 at that time. And we had three kind of research or goals for these cohorts. We wanted to quantify health inequalities over time and understand the factors that are contributing to these trends. We wanted to facilitate environmental health research by taking into account where people live annually. We also wanted to increase the use of these linked census data sets by making them available in the research data centers. So that was step one. So we knew what we wanted to achieve. So then we had to put this on paper. So the approval process, step two, I think it's good to remind ourselves that by its nature, microdata linkage is privacy intrusive, and Statistics Canada undertakes microdata linkages in cases where the public good is clearly evident and outweighs the privacy intrusion. And privacy intrusion results from the fact that information for a particular individual is being put together in a manner that is generally unknown to that individual. And as in the case with any microdata, in some situations, this could disadvantage the individual. So the mitigating measure is that by definition, statistical analysis is not focused on an individual, and only non-confidential statistical aggregates are produced. So that's kind of what the overall process. So for us, you have to describe your specific objectives and why it is important to do it. Determine the feasibility of whether the linkage is even possible, and this is done usually through initial consultations with the social data linkage environment group, or through subject matter contacts such as myself. And then it follows a kind of prescriptive review process, and then once it's approved, it will be posted on the Statistics Canada's website. For CanCheck, as you saw in the previous slide, it is built on previously approved record linkages, but we wanted to create a standardized series of them. So our specific objectives were to examine the nature and extent of socioeconomic inequalities in health across Canada over time. We wanted to examine the nature and extent of health inequalities across different population groups, such as Indigenous identity, immigration status, and ethnicity across Canada over time. We wanted to detect possible elevated risks of mortality and cancer in specific occupations and industries where health risk is known or may be occurring. wanted to assess the impact of long-term exposure to ambient air pollution on human health, as well as examine the impact of other environmental factors such as the built environment, social environment, natural environment on human health. So it was very broad objectives. We had to obtain approval from all of the dataset custodians, which included internal divisions within Stats Canada, such as Census, Health Division, as well as outside organizations that give the data, that give us the data, which is the Canadian Institute of Health Information. And then we ended up having an updated series of CAN checks, and it was approved in 2016 and is available on the summary of that linkage project is available on the Stats Canada website. So I'll pass the baton over to Chantal to talk about working with the social data linkage environment.
Bonjour tout le monde. Moi, c'est Chantal Poirier. Je suis la chef intérimaire de l'environnement de couplage de données sociales, so the Social Data Linkage Environment. I'm very pleased to be here today to talk about my system, my program. I'm just looking at my notes. So today I want to give you just an overview of SDLE roles in a linkage project that is conducted in collaboration with subject matter area. So in that case, it's with Mike. So I'll just start by explaining what is the social data linkage environment. So the SDLE is a secure processing environment that facilitates the creation of linked population datasets for social analysis. So with the SDLE, we can link multiple data files, which allows us to explore data in a whole different way. So data from all areas of the social domain, such as education, immigration, justice, health, income, can now be linked to create a new data file without needing additional data collection. So what is great with SDLE is that once a file is linked, either admin or survey file, it's always available to be associated to other files that has been linked into the SDLE environment. And again, this is possible upon obtaining linkage approval, as mentioned by Mike. Next slide, please. So to deliver the final project, SDLE collaborates with different partners, such as subject matter experts and the data access division. So the total cost of the project will depend on the following. So we have to choose which linkage method will be the best for the project. So we can do a deterministic linkage or probabilistic linkage. We also have to work out the linked output as specified by the researchers. And we have to look at any special processing requirements to do the linkage. And to that, we add the cost for subject matter area and data access division implication. Next slide, please. So as explained by Mike earlier, there are a lot going on before the linkage happens. But once the linkage is approved and all data files are received at StatCan, SDLE can do its work. So two linkage methods are possible. So the first one would be the deterministic linkage that is used when unique direct identifiers are available in the file. A unique direct identifier will be a social insurance number or an hospital insurance number, for example. So in that case, we would do a direct match only on SIN. So that type of record takes less time because there is not much data processing and because the linkage is done on only one variable. Unfortunately, such unique direct identifiers aren't available on files often. So this is why SDLE usually conduct probabilistic linkages. So as shown on the slides, the left box. So with the probabilistic record linkage, personal identifiers of a cohort file, such as name, date of birth, address, are compared to personal identifiers that are contained in the social data linkage environment derived record depository, the DRD. So that derived record depository is an historical longitudinal database that combines personal identifiers of Canadians that we have built using different admin files, such as birth, tax, and immigration files. So all records in that DRD is assigned a unique statistical number called register group ID. So once a match is made between the cohort file and the DRD, the concordance between the cohort file's primary key and the register group ID is stored, and that can be used later to merge different data files together. So if two records of two different cohort files match to the same SDLE register group ID, we then know that the two records from the cohort files are the same person. So that type of linkage can take up to 40 days. So this is a longer processing time because there are a lot of variables to prepare for the linkage. And our methodology team needs about 20 days to do the internal record linkage, which will identify duplicates in the cohort files. And they need another 20 days to find matches between the cohort file and the DRD. And that part is called an external record linkage. So the G-Link software is used to do the linkage, but manual interventions are essential for attaining a good linkage rate. Next slide, please. So when the linkage is completed, SDLE prepared the linked outputs as specified by the researcher. So in our products, we always refer to two concepts. So the cohort, which will be the population to be studied, and the target, which is the what you want to know about the cohort. So three products are offered. We have a linked key file. So in this file will contain only the unique identifiers, the primary key of the two linked data sets. We also offer a linked outcome file. So in that case, you'll have the unique identifier of the cohort data set and the analytical variables of the target data set. And the third product is a linked analysis file. So in that case, you'll have analytical variables from both the cohort and the target file. So key files can be delivered way faster than the two other products since no data manipulation is required. So for the can check, for example, to have that product updated in the RDC, SDLE has to conduct about 5 different linkages during the year. So we have to wait for the files to be available for the linkage, and all the files are not available at the same time. But once they're ready, the linked outputs are transferred to subject matter area, who takes over the project. So I'll turn it back to Mike.
Thank you, Chantal. So you can see that the record linkage is, it is a little bit complicated, but you do get a good result at the end usually. And when you do get that key file or that data file, it also comes with a report on how the linkage was conducted and any issues that might have arisen during the linkage process. Now, beyond that initial linkage assessment, it is the responsibility of subject matter division or the client who will kind of assess and identify any other additional biases or limitations on this newly created linked file, kind of from a research perspective, kind of from why we wanted to create the file in the first place. So does it meet the needs of the research question? And this is really kind of a high-level assessment and isn't really meant to catch all the different nuances or biases that might exist in a file. So it really is kind of like a headline type biases and not every single issue that might be around that file. So the goal really is really just important limitations, identifying errors. And you want to do this before making the file available to the broader group. Next slide. So in terms of the can check, the can check had been around for several years. So the level of assessment has become, it's not new linkage per se. So it's a little bit more straightforward. But some of the activities we've done in the past include looking at death and cancer counts, by year of follow-up. We usually calculate age-specific mortality rates, annual mortality rates. We compare CanCheck results to official statistics to help us understand or identify any major discrepancies between the two different data sets or data sources. We also wanted to have a better understanding of any cohort effect or CanCheck cycles. So, you know, for people who wanted to examine trends over time, it's important to know whether each CanCheck has the same type of bias to help with trend analysis. In terms of some of the things that we did find was that there were some important biases around infant mortality, that the CanCheck data sets, the way they're designed, really cannot be used to calculate infant mortality. And you know, the coverage issues were perhaps more of a documentation issue, but you know, in terms of what ages were included, some of the health outcomes aren't available for all provinces or territories, or stop in certain years. So these were some of the things that we were able to identify. So step 5, so creation of weights, if applicable, as well as vetting rules. So, you know, are all linked data sets weighted? The answer is no, but some are and some are not. So why would we weight the link file? Well, if your goal is to have a linked file that is representative of the target population, you probably want to have weights. They're really designed to minimize bias that may exist from the linkage activities, especially if you have something that might be systematically different. The weights are generally created and developed by methodology, and they're assessed by both methodology and subject matter divisions. And then once during this assessment process, weights are tested and refined before they're finalized. So this process can take a bit of time. In terms of vetting rules, if you work in the research data centers, you're probably quite aware of vetting rules, and they're really there to protect the confidentiality of sensitive statistical information. And it's really a core value and legal obligation of Statistics Canada, including those that work in the research data centers as deemed employees. Vetting rules are developed and created by methodology in consultations with the data set custodians. In terms of the CanCheck, because we were creating a series of CanChecks, we wanted to use weights. So we listed methodology to create cohort weights and bootstrap weights for each CanCheck cycle. We examined the weighted and the unweighted results and the effect of using bootstrap weights on variance estimation. It is allowed to use CanCheck with and without weights, but we give that option to researchers. And we also wanted to assess how representative each CanCheck was to the target population for that specific cycle. In terms of the vetting rules, I mean, when the first CanCheck came out in 2008, the vetting rules have changed a little bit, in part because more data have been added to the CanChecks. We have more of them, and we also wanted to ensure coherence across the different Stats Canada data sets in the research data centers to help the analysts in the research data centers perform their vetting job. This would include random rounding, minimum cell counts, smallest geographic areas. So the vetting rules will change, and they have changed for the CanChecks over time, and they're an important part of the process. Step 6, documentation. You know, it might go without saying, but you know, a data set without documentation is not really useful to anyone. So you really want to have at least enough documentation to be able to use the file. In my experience, this is typically the last step, and the goal is really to aim to provide users with enough information to use the file properly, such as fitness of use, as well. This may include a user guide, a data dictionary, file layouts, methodology reports, etc. It really depends on how widespread the data set will be used. Also, it depends on I guess the level of funding we have for the amount of documentation that we produce on a file. For the CanCheck, we published an updated CanCheck cohort profile and health reports in 2019, outlining the process of how the data sets were created and some of the limitations. We also created user guides for each CanCheck cycle. And because we didn't have a lot of funding, we really did piggyback on existing documentation for those data sets that contributed to the CanCheck linked file, which would include census documentation, mortality documentation around the Canadian Cancer Registry, for example. And now I'll pass the baton on to Chris, who will talk about placing the file into the research data centers.
All right, can share my screen now. Okay. So good afternoon, everyone. My name's Chris Troke, and I'm here to represent the data management team in the data access division. So I'll be going over our internal processes involved in disseminating data to our networks and including the research data centers. So the goal is really to provide a high-level snapshot of the work involved from subject matter handoff through to dissemination, which obviously Michael and Chantal just discussed. So the process is the same for all of our standard data releases, including our linked data products. However, for some of the larger linked data sets, the actual time to release can be significantly different, which I'll show you today. So my team's part in the process typically begins by coordinating with our internal subject matter partners. Usually they'll notify us when a new data set is available to be disseminated. So our first order of business is to review what's been shared with us and to ensure we have all the data and documents required for disseminating the microdata, as well as the essential items. So the following are key for us to be able to prepare the data and send it off. So obviously the master file itself, which we typically receive in SAS format or the raw layout cards. Obviously bilingual documentation such as codebooks and user guides. For linked data sets, having a well-formed user guide that explains how to perform the linkages, specifically if we receive linkage keys, is a vital element to assist our researchers with their work. So this document should really spell out the identification variables that are needed to be included in the code to create the linked outcome or analytical files. So the document should also ideally specify what other dataset access requests might be needed to complete the merge. As an example for CanCheck, a researcher might want to link the core CanCheck data via the key file with Census 2016. So the guide should detail which unique ID variables can be used to build the analytical file by merging the key file with the census master file itself. So this is typically crucial information, as for any of our linkage keys, the researchers will need to merge the data themselves, and having the technical information in these guides is very, very useful. So before we can move to the data preparation and staging phase, we also need a sensitivity score. So this number is reviewed and confirmed by subject matter and gives us kind of a high-level assessment of how sensitive the data is. So the score also determines where the data can be accessed from. So for example, anything scored over an 8 cannot be accessed virtually. So we also require a report indicating the use of tax data for internal auditing purposes, as well as vetting rules, which Mike just discussed. So the vetting rules are obviously developed between subject matter and our research data center methodologists, but they're managed and maintained by our team. So if any of these requirements are not fulfilled, further discussions and coordination with our partners might be necessary. Once everything has been received and in good standing, we'll begin preparing the data for release. So the first step in preparing the data is making sure the folder structure matches our internal convention. So previously, this was a manual process where we'd have to build up the structure based off of a template. However, recently, we've now begun automating much of the process, and our programs will build the structure and file the contents into the appropriate subfolders. So the most important part of this step is to make sure the top level folder name matches how we've named it in our internal systems, as this will eventually be tied to permissions across the networks. So we also keep all original files in a subfolder as well. This allows us to host an archive, essentially, of all the original data as received by subject matter. And if any errors are noticed in staged data files, we can always revert back to the original copies and restage. So adhering to this standard enables our analysts ease of access as well. They'll know where to go to find specific data file formats or documentation, and they can also compare the staged data with the originals. So once the folder structure has been built, we then rename all of our data and documentation. So this was also once a manual process, but recently we've begun working towards automating it to obviously reduce human error that might be introduced. So using a few quick PowerShell macros, we can simply add a few inputs related to the naming conventions as shown on screen, such as our F and T numbers. And the program will apply the conventions to all data and documentation within. So the name typically starts with the English and French survey or data acronym, followed by the year or cycle. Now the F number is an internal classification that allows analysts to know whether the data is linked, F3 for example, or a standard master file, F1. The T number applied also denotes which type of documentation the file is. So T15 is used for codebooks, as an example. So an important note is that while we strive to use this as a hard standard for all of our products, we're often faced with certain specific system limitations, SAS character limits being a major one, as well as long file paths. So at times we kind of need to get creative in how we name the files. Many products such as CanCheck contain multiple data sets or linkage keys, and spelling out each acronym in our product names or folders would create many SAS issues, prevent us from transferring data through the networks, and as well the file names can exceed system limitations. So once our main SAS files or layout cards have been structured and renamed, we move to the data staging step. This process can take two forms, and both are mostly now automated. If we receive a SAS data set from subject matter, we simply add the path into PowerShell and run a code to create the SPSS and Stata versions. So these are the three formats that my team is responsible for delivering and maintaining. Now, if we receive layout cards, we'll first need to build the data set manually through syntax files, and then we can proceed to running our PowerShell code. So ensuring proper file names are in place prior to the step will also ensure the newly staged SPSS and Stata file names are a one-to-one match with the input SAS file. So this process, while mostly automatic, can also be very resource intense. So obviously for many of the large linked data sets, the files can number sometimes in the hundreds and approach 1 terabyte in size. So it can really take close to a full week at times to run the staging tools and to output the SPSS and Stata files. So if the job fails for any reason during this time, we often have to restart it from scratch. So one other important note about the file formats relevant to our linked data sets is that Stata often cannot be used for the larger data sets. Using SAS or Python is usually recommended and will perform better. So once the data is structured and staged, we're almost ready to transfer. However, we need to perform a few administrative tasks, update our internal systems, and ensure the product is active. So we need to assign a product ID for each new data release. This is done by entering standard mandatory information into our client relationship management system. So this will also facilitate contracting and access and ensures we properly track our data as it travels through the networks. So adding our products into both our data available webpage and microdata access portal for standard releases is also a mandatory step, and it allows our researchers and the general public to view our available data holdings and apply to access them. So at this point, all the data preparation from the data management team should be completed and the products now exist in our systems. We can move to the actual transfer step. So our team is now responsible for not just transferring to the RDC network for all of our standard releases, we now also transfer into the Federal Research Data Center network, as well as our virtual data lab. So this step can also be very resource heavy as well. So obviously it's mostly automatic, just simply dragging and dropping files, whether via external hard drives or into the cloud network. For the large linked data sets, this can still take several days. So as an example, transferring a large linked data set to the RDC network involves on-site access, logging into our network A, transferring to a portable hard drive, followed by transferring to the actual RDC network. And from there, the analyst will still need to download the files locally. So as I mentioned before, the data can sometimes approach 1 terabyte in size. And this can take a full day to get onto a hard drive and another full day to get into the network. And again, if the transfer fails or is corrupted for any reason, we often need to restart. Due to our resource limitations at times, we often run these jobs overnight and on weekends so we can maximize the transfer capacity. So with the admin task completed, and once the data has confirmed to be in place on the networks, we need to create the data group to facilitate permissions. So while this is a relatively simple task on our end, we must follow a specific data group format and submit a service request. We still need to wait on IT and receive confirmation from our support team before we can officially disseminate the data. So obviously the security must be in place before researchers can access the data. So the last step for the data management team, the last step for the data management team is to send off the actual release note itself. So once this has been received, it is usually safe to assume the data is available for access. We have a few different templates to work from, including a larger linked dataset release note that holds standard information. We also send multiple versions of our note off, one to external partners, such as the CRDCN, and then they add that data to their website. And another one to our internal RDC staff that contains a little more specific technical internal information. At this point, anyone is now free to request access to the data, and it can be downloaded to local RDC servers to facilitate access via our RDC analysts. So that wraps up the data management team's role in the process. Once the data has been released, our roles transition to support and maintenance of the data repositories, performing updates, archiving old data, and managing functional inboxes to respond to requests. So that's it for me, and thanks for listening, everyone.
Thank you, Chantal, Mike, and Chris, for your talk. Very good for everyone to see how the cheese is made, so to speak, or how the sausage is made, I guess is the expression. So I have a few questions because we kind of just every data session kind of collected some SDLE or linkage related sort of questions as we were going along, and since we've got Michael here from Health Analysis Division, a lot of them were from the health session. So maybe I'll put them to the three of you, and if anyone knows, we can address them. Is there any plans, and you know, researchers, they just want to know what linkages are coming. Has there been any talk, any plans of linking the longitudinal administrative data bank to the NACRs? So that linkage to the discharge abstracts has been done. Is anyone on the panel aware of a linkage to the ambulatory care records?
No, I don't. I think you have the wrong person around
Okay,
the table.
Well, I kind of put you on the spot, so forget about it.
But just one point I can share is that there's a difference between like a specific linkage for specific use that we can have like LAD linked to NACRs, but for a specific research. But to have it as a general product in the RDC, that's a different story. So it has to be approved for a general use.
So is there, well, I'll ask a follow-up question then. Is there a sense that more things are getting proposed as being created for general use, or are things mostly being pitched as a one-off product? Like I can imagine there'd be some extra overhead to asking for general use. Is there institutional pressure for pushing things towards general use when possible?
I think when the projects are initiated, it's for like specific use, but at one point users are made aware that it exists, and then there are more needs. So maybe Chris would have more information about how products are requested in the RDCs.
Yeah, I know from our end, more recently, we're trying to steer away from the exclusive accesses as much as we can. It's a little easier to facilitate when we can just release it to one repository and one network and allow everyone to access it, with obviously their application request being approved. It just kind of streamlines things a little bit in terms of obviously managing the data, and we don't have one cut going here, one cut going here or there. But that obviously depends on what kind of an agreement I think is in place with the client. Okay.
I'm going to ask another question. Audience members, the Q&A box is there for you. It's not just for me. There's there's a new linkage process, right? And Mike talked about going through the CAN checks and how that was a huge ordeal, and partly because it was one of the first ones ever. But I think I saw on the timeline there sort of 15 years from, hey, this would be a good idea to it being available. Obviously things have sped up a little bit from that since then. But I guess are there any differences in the process when it's something that's been done, right? I mean, we're thinking about these linkages that are happening, over and over again. What's the differences, if any, in that, so that maybe processing time can be sped up a little bit?
I think the only thing I'll mention is, with the creation of these SDLE, It has increased the processing time. It has reduced the cost associated with linkages. When we first did the 1991 census mortality linkage, that was a grant from CIHR, and I believe at the time, which included some analysis, but it was I think it was about $500,000. It was quite a bit of money. It was quite an ordeal, and now with the way the SDLE is organized, multiple linked products can kind of piggyback on those linkages that are already done. So if I had, I think things are a lot more timely than they used to be, because linked files were very kind of one-offs 5-10 years ago, and now it's almost like a routine process here at Stats Canada. So I think it's now maybe think of a two-lane. The two-lane highway was great when it first opened, and then everybody started using it. So suddenly you got to put that extra lane in, because it's 2 lanes are no longer enough. So I think it's maybe a matter of just so many people want to do it, as opposed to actually. The system, the process has been greatly improved over the last 5-10 years, in my opinion.
Okay, so our next question. Our next question is for Chris. When you get updated documentation for a data set, what's the process to have it moved into the RDC? And then what's the process for deciding, we know some of the documentation can be released and people can just have it by email, and other things it's not the case. So what's the process with documentation there?
So it really follows the same standard kind of release procedure as any data set. If we receive a new or updated piece of documentation, we'll obviously put it into its correct folder structure and rename it according to our conventions, and then place it into the RDC network, usually as a version 2 update to an existing data set. And obviously from there, the analyst will then download it and can make it accessible to researchers, I think, as long as it's non-confidential. So however, that's the second part of the question, I believe. If we receive documentation that's identified as non-frequency with no actual data or counts in it, we can flag it as being non-confidential, and that's obviously free to be shared externally. But usually we fall back to our subject matter colleagues to let us know if something is non-confidential. In some cases, user guides will be considered non-confidential again, but it's up to our internal subject matter partners to let us know what can be shared and what can't be.
Okay. Got a question about public use files. What are the tweaks that are made to data sets that change them from being a confidential RDC micro data set to a public use file? Anyone at all?
So I have a bit of knowledge on that one. I used to work in the public use microdata file section, and I believe a lot of the categories get grouped, so turned into discrete variables. A lot of rounding happenings. Yep. And I believe a lot of more sensitive variables will get completely stripped from the file. I think those are the major things to make it less sensitive and more accessible to the public. That's from my experience done by, depending on the subject matter area, they'll take care of that for us, usually.
So if you're interested in learning more about that, Chris and I did a talk last year together on the sort of gradations in the microdata access continuum that can be found on our website at crdcn.ca. So if you want to learn more about that, there's a resource there for you. We now have a question. Mike, you had a throwaway line about the CanCheck not being great for infant mortality. It was an example, but this questioner is interested in knowing a little more about that and asking, why maybe it hasn't been linked to the vital statistics birth and death and infant mortality databases.
Yeah, historically, there was a linked birth events to 1 year mortality after a birth. Our colleagues in the Center of Population Health Data, which would be part of that file, which was funded by the Public Health Agency of Canada. In terms of linking birth events to mortality events, we do have a file called the Canadian Census Birth Cohort. It's in the RDC. It's 1996. The acronym is CAN-BCC. We have the 1996, the 2006, and I believe The 2016 birth cohort will also be in the data set for those that want to examine perinatal outcomes. Kind of follows the same process. It's about 2 years of births that occurred just before Census Day that were linked to the census as well as deaths. So you can probably find that on our website if you just Google Canadian birth census cohort.
Indeed. Okay, well, thank you, Chantal, Mike, and Chris. We're out of time for this session. I'm bringing in our next panelist and moderator to talk about the QDRC. So thank you again.
Thank you.
Great, thank you.
Thank you.
Welcome. Before we turn it over, this is the last you'll be seeing of me because we'll be just ending the day after our last panel and our closing remarks. I do want to thank everyone from CRDCN behind the scenes. You've seen a lot of CRDCN faces today, but there's some CRDCN faces you didn't see, specifically Perry Abdullah with me in the research portfolio, and our communications team, who of course were central and pivotal in not only getting great registration numbers for this event, but making sure that it went as smoothly as it did. Any academic paper, I'll just put the disclaimer that all errors are my own. So anything that didn't go smoothly, you can blame on me. Joanne should be here. Monia should be here, and we just need to make sure that Kui is here. And we will get going with the QDRC panel. Again, all the videos will be posted on our YouTube channel. There's a translation link that's popping around the chat if you're interested in reading the transcript in French. And it's been a pleasure to have you all with us today. And I am signing off for me, but there's still 2 more sessions left.